Okay, here we have some equations that are useful to us for what we're about to do. You can find the same information on the slides. And so the r squared equals x squared plus y squared, we've been using that when we find r, when we found r. And as long as x is not equal to 0, we can get a tangent on the angle theta as y over the x. But if x equals 0, we're going to use pi over 2, and then r will just take on the y. So if we did a pi over 2 and y is positive, that's going to take us up here. But if y is negative, then r is negative, and it'll drop us down here and take care of that situation when we're actually talking about negative pi over 2. If we wanted to keep r positive, we can make theta a negative pi over 2. Okay, so we'll get back to these equations, equivalencies. And this is also just a rundown of what we've done. Generally, we'll plot the point, and if either x or y are 0, we're in that scenario where it's on one of the axes. And we looked at that first, and then we looked at the conditions when it was in one of the quadrants. And what's really nice is down here, you've got information. So remember our quadrants, quadrant 1, 2, 3, and 4. And if we're anywhere in quadrant 1 or 4, that's where the tangent is defined. And if we're in either quad 2 or 3, then all we have to do is add pi to the inverse tangent to put it back in its right place. Okay, so for this example, here are the tools that we're going to use. We've got, generally when we're trying to convert equations from polar to rectangular form, you've got these options here. Multiply both sides of the equation by r, or square both sides of the equation, and that is going to use in combination with these equations 1 and 2 here. So remember, x equals r cosine theta and y equals r sine theta. So our goal is to transform the equation r equals 6 cosine theta from polar to rectangular. So the thing that's going to help me decide this here is that I know r squared in terms of x and y, and I know x in terms of r cosine theta, right? So if I square both sides, I'm sorry, not square both sides, so if I multiply both sides by r, I would get over here r times r, and then over here I'll get 6r cosine theta, and then I've created expressions that can tap into these equations. So I've got r squared equals 6r cosine theta, and I know that in terms of x and y, I can substitute for r squared. It's equivalent to x squared plus y squared. Now over here, r cosine theta is otherwise known as x. So on this side we end up with the 6, and then we just take and replace r cosine theta with its equivalent x. Now everything here is in terms of x and y coordinates, so we've converted it to rectangular coordinates. And let's talk a sec about what the graph's going to look like. Okay, and if we begin to think in terms of rectangular coordinates, what have we got here? So let's subtract the 6x. And we have x squared minus 6x and plus y squared equals 0. So we could think of this like a general form of a circle, if you remember what a general form of the circle is. Most of us are more comfortable with x minus h squared plus y minus k quantity squared equals the radius squared. So let's put this circle into the standard form for a circle. Okay, because the general form is not really easy to recognize, but when we have standard form, we know that hk is the center and r is the radius. Okay, so what we can do is, if you remember how to complete the square, we take the b over 2 and square it. So I'm going to take negative 6 over 2 and square it. That's going to be 9. So if I add 9 to both sides, I have x squared minus 6x plus 9 plus y squared equals 9. I have to add the 9 to both sides. I'm creating a perfect square for this, and then I have to balance it on the other side by adding that same 9. Okay, so that's going to give us 6 over 2 is 3, so we created a perfect square of x minus 3 plus, now if we want to think of this as y minus 0 squared, and that equals 3 squared. So we're talking about a circle centered at 3, 0 with a radius of 3. Okay, on this last example here, we're going to go the other way. We're going to take 4xy equals 9 and convert it into polar form. Okay, and again, we're just tapping into these theorem and equations 1 and 2. So x is the same as r cosine theta, and y is the same as r sine theta. So we're just going to substitute that in place. So 4 times r cosine theta for x and r sine theta for y. And we don't need to do anything on this constant. And so let's simplify this. I've got r times r in there, so we can bring that out as 4r squared cosine theta sine theta is equal to 9. Now there is something else we can do if we recognize it. One of our formulas that we had from before, the double angle formula, 2 times the sine theta cosine theta is equivalent to the sine of 2 theta. So we can take this 4 and split it into a 2 times 2, right? I can take a 2r squared and then multiply that by 2 sine theta cosine theta. I'll just reverse the order of these factors. Okay, so if we recognize this double angle formula, then we can substitute for it the right-hand side sine of 2 theta and makes this a little shorter or more simplified. So this is going to be 2r squared times the sine of 2 theta equals 9.